Hi there, I'm Dr. Jani Harkonen. I represent Product Management Research and Education at Industrial Engineering Management, University of Oulu, Finland. Our paper is titled Productization, Product Structure and Data for Supply Chain Traceability. Traceability is important for companies to have the ability to identify the origin, movements, and associate information relating to products and the origins of raw materials, components, parts, and even data. This is valid for company internally and also outside across the supply chain. And we need a combination of internal and external traceabilities to cover the supply chain end to end. There are different types of supply chains, and it is important to understand that traceability is a key concept regardless of the types of products or supply chains. Traceability in general, it enables, for example, identifying sources of quality issues, specific sets of products or batches, tracing the history of products, demonstrating meeting requirements and compliance with regulations, and it also supports change management and is important for product safety. It is important to have transparency through the supply chain, to have visibility over the products, the components, materials, production practices, and sustainability. Traceability is specifically emphasized in safety critical industries, for example, food, medical industries, or aviation. And it is also the data that are vitally important in this context to manage products and related information. The traceability, it must be seamless between the designs, the operations, maintenance, and the IT systems. The linkage of traceability to productization and product structure, this is something that has been particularly deficient in the earlier studies from the supply chain perspective. If the concept is not familiar to you, productization generally it relates to the offering. It involves activities to ensure that we can sell, produce, deliver, purchase, and use the product so that the product remains as the same product throughout, so that we can have control over the product. The concept also links to product structure, and we can view these things through commercial and technical representation of the product. It is actually the product structure that provides the backbone for data. It's important to consider actor-specific business processes, the IT systems that are linking to the business processes, the products, and also the data flows to make sure that we have consistency for data. These combinations, they affect traceability. The reality in many companies, however, is that the products are not necessarily clearly understood, even within the companies, and they are not in full control. It may be that the processes have not been well defined, and the product structures and the productization logic are not consistent. And also it may not be clear who owns the data. End-to-end supply chain traceability is a complex whole, and also traceability does cost money, so we kind of need to be clever about it. We need to understand the supply chain in question and the related actors, and this is a series of internal and external traceability. So this involves the traceability of a product and the structural elements within a company and the movements between traceability partners. So we need to understand the product flow, and we need to have a clear logic for obtaining data from individual companies. In order to benefit from the available data for traceability, the data flow architecture need to be understood and optimized. A generic data flow architecture, it can consist of layers to carry, capture, and share data along with the product flow. And we also need an application layer to have suitable interfaces for traceability. The data carrier layer, it carries the product-related data using identifiers. This can be barcodes, RFID, QR codes, or even sensor data. So a variety of technologies can be used for traceability with the purpose of identifying products, components, and so on. There are differences between technologies and how well items can be distinguished and how the information collection is done in practice. Different technologies can work for different purposes, and a single technology may not be enough for the entire life cycle, but we need a combination. Traceable objects outside companies, they need to be identifiable by multiple parties along the supply chain. The internal traceability may apply internal codes which are not necessarily meaningful or understandable by outsiders. Traceability, it also links to a multitude of standards, and there are related regulations which also must be acknowledged. The data capture layer, it involves data readers and middleware. Then the data sharing layer, the manipulation and exchange of product identifying information and systems events among stakeholders. And then the application layer for the communication protocols and interfaces for applications. So we need this kind of data flow architecture for visualization, as these things can be rather challenging to understand as a whole. The productization logic of an individual company links to the company-specific orchestration of business processes, IT systems, and data, and there can be certain company specifics existing. Even though, or regardless of this, it is possible to synchronize the productization logic and product structures across the value chain to improve traceability. So in this illustration, we have the main company and the suppliers linked through the product structure. The traceability across the supply chain, it can benefit greatly from consistent product structure and productization. And actually, it is the productized product structure that provides a frame for data within each individual actor and allowing the data to be dealt with in a consistent manner within the company and also within the supply chain when the data is made available. We're kind of looking at the whole over supply chain to address the deficiencies of previous studies by combining a literature review and exploring a real-life example of supply chain traceability. The product in this case provided by the main company is a smart windscreen containing a built-in display, the windscreen, a heating system, and a camera system. The offerings by 5 different interlinked companies were productized and the common product structure logic was considered. The traceability was considered in the context of the validated logic without considering individual component suppliers. I will not go deeper to the case, but overall, as the main contribution of this study, we have synthesized a model to consider end-to-end traceability over the supply chain, the product flow, and the traceability data. We highlight the role of productization and the product structure logic to provide consistency for data within individual companies, but also to support traceability between companies. The companies, they need to be willing to share information, not to function only at an acceptable level, but to enable traceability through the entire supply chain. And here, the consistency, it is the key, and the product structure provides a frame for data to enable data consistency. This kind of helps to avoid dependency on company silos, IT architecture, and the pitfalls of IT integrations. In general, we can use a variety of technologies, specifically the internal traceability. It can benefit from the combined logic of business processes, IT, and data, and the end-to-end traceability in a supply chain is a sum of internal and external traceabilities. So all in all, we need to understand the whole, the supply chain, the nature of products, the product flow, and the data flow architecture to link the data for supply chain traceability. Thank you.